Students, today's lesson is about GCF, which is greatest common factor. You learned how to do this back in elementary and middle school. Let's real quick just look at a GCF problem that only has numbers. So if you were trying to find the GCF of 8, 12, and 24, then the GCF is the biggest number that will divide evenly into all of the numbers. So a strategy that I like to use is I like to start with the smallest number. Will 8 divide evenly into all those? And when I say divide evenly, that means you type it in the calculator and divide it, and you don't get a decimal, you get a whole number. So if I type in 12 divided by 8 in my calculator, I will not get a whole number because 8 won't go into 12 an even number of times. It will go into 24 an even number of times, but it has to go into all three of them to work. So if the smallest number doesn't work, then I start thinking about the factors of the smallest number. So the factors of 8 are 2 and 4. So then I'm going to try 4. I know it goes into 8 because I just did that. Will 4 go evenly into 12? Yes. Will 4 go evenly into 24? Yes. So 4 is the GCF of 8, 12, and 24. So you start with the small number. If that doesn't work, then you think of factors of the small number. And you can use your calculator to help you with the division. If you'll remember back to the first semester when we learned about the distributive property and the double rainbow.
Whoa, that's a full rainbow all the way. Double rainbow, oh my god, double rainbow. It's a double rainbow all the way. Damn.
Remember, we took the number that was on the outside here and we distributed it to everything on the inside, and that's why we called it the double rainbow. 5 times 2x was 10x, and the double rainbow was all about multiplication. And then 5 times a negative 6 was a negative 30. Well, today we're going to do the exact opposite of that. We're going to take 10x minus 30 and we're going to end up rewriting it as 5 times 2x minus 6. And that's called factoring. And factoring is when you go backwards from multiplication, and it's based on division. Here's the first example we're going to work with down here. 12x to the 5th, 6x to the 4th, minus 4x squared. So the first thing we have to do is we have to find the GCF of the numbers 12, 6, and 4. So 12, 6, and 4. So my strategy earlier was to start with the small number. Will 4 go into 6, and will 4 go into 12? Because we know it'll go into itself. And it is the answer to that is no, it will not go into 6. So then you have to think of the factors of 4, which are 2 and 2. We know 2 will go into 4 because it's a factor. Will 2 go into 6? Yes. Will 2 go into 12? Yes. So 2 is our numerical GCF. So we're going to pull it out to the front. Then we have to find out what's the GCF of x to the 5th, x to the 4th, and x squared. Here's the steps that I use. You got to look for common letters. So that's the first thing. And then step 2, lowest exponent. So what common letters do 12x to the 5th, 6x to the 4th, and negative 4x squared have? That is x. And then we go with the lowest exponent. 5, 4, 2 is the lowest exponent. So that's what's going to be on the outside. That's what was double rainbowed to create this problem. Okay? I'm actually going to write it down a little bit further and erase that to give me some room to try something different. Okay? Just like I said a minute ago, double rainbow was multiplication, so factoring is the opposite of that. So instead of multiplying, we're going to divide out 2x squared, 2x squared, and 2x squared out of all of these. There's our parenthesis. So when I divide this, 2 divides into 12 and leaves us with 6. x2 and 5. If you remember the rules that we did just a couple of weeks ago, 5 minus 3 is x2. 2 goes into 6 3 times. 4 minus 2 is x to the second. Here, negative 4 divided by 2 is negative 2. X to the 2 minus 2 is 0. X to the 0 goes away. This is our answer. Okay? If we wanted to double check it, we could easily double check it by double rainbowing, which would actually be a triple rainbow here. That'd be 12x. Oh, right here, that's a mistake. 5 minus 3. 5 should be 5 minus 2, so this is 3. So just by double checking my work here, I was able to find out a mistake. 2 times 6 is 12. x2 and 3 makes 5. 2 times 3 is 6. x2 and x2 makes 4. 2 times negative 2 is negative 4. x2 and nothing is x2. So this is the right answer. So you were able to see the importance there of checking my work. Let's take a look at some other examples here. We look at 5 and 15. So 5, 15. We ask ourselves, will 5 go into both of them? And the answer is yes. So 5 is going to get pulled out front. Common letters, no common letters. So 5 is the only thing coming out front. So we divide them both by 5. 5 goes into 5 one time, leaves an x. Plus 5 goes into 15 3 times, leaves a y. And we just wouldn't write the 1. Double rainbow to check it. 5 times x is 5x. 5 times 3y is 15. Easy check. Here we look at 3 and negative 9. So 3 and negative 9. Will 3 go into both of them? Yes. Do they have any common letters? Yes. And what's the lowest exponent of the common letters? It would be this one, which is x1. That's our GCF. So we divide both sides by 3x. 3 goes into 3, leaves us with 1. This is an x1, so minus 2 minus 1 leaves us with x1. Negative 9 divided by 3 is negative 3. x1 and x1, 1 minus 1 is 0, so they're not there. This would be 3x times x minus 3. Double rainbow to double check. 3x times x is 3x squared. 3x times negative 3 is negative 9x. Okay. Here we have 4 and 14. 4 will not go into 14, so the factors of 4 are 2 and 2. Will 2 go into 14? Yep. So 2 comes out. Any common letters? Nope. So we divide both by 2. 2 goes into 4, leaves us with 2y. Negative 14 divided by 2 is negative 7. Double rainbow to check. 2 times 2y is 4y. 2 times negative 7 is negative 14. 6x squared, 12x, 21. So 6, 12, 21. Will 6 go into all three? 6 will go into 12, but it will not go into 21, so we think of the factors. Will 3 go into all of them? 3 goes into 6, 3 goes into 12, 3 goes into 21. So 3 is our GCF. X squared, x, no x. So they do not have any letters in common, so we're just pulling out a 3. 3 goes into 6 2 times with an x squared. 3 goes into 12 4 times with an x. 3 goes into 21 7 times. Triple rainbow to check. 6x squared, 12x, 21. Here the numbers are 1, 8, and negative 1. So you look at the smallest one. Will 1 go into all of them? Yes. So 1 would be the GCF. Okay? But 1's not going to change anything, so we really don't consider that a GCF. Then you look to see if they have any common letters. A. So A is a common letter. They don't all have B's, so the GCF of this one is just an A. A divides into A, but you can't just let it go away. Anything divided by itself is 1. 1 divides into 8 here and leaves us with 8. A1 subtracts out of that and leaves you with an A. Nothing happens to the B, so we just bring it down. Here, A's cancel out to make a 1, so this is minus B. A times 1 is A. A times this is 8A squared B, and A times this would make just minus AB. So this is our answer. Here, 7, 28, and 35. 7, 28, 35. Does 7 go into all of them? The answer is yes. Do they all have an M? Yes. What's the least number of M's? M to the 1. Do they all have an N? No. So 7M, 7M, 7M. 7 divides into 7 and leaves us with 1. M and M cancel. 7 goes into 28 and leaves us with 4. M and M cancel. 7 goes into 35 5 times. M minuses out one of those and leaves you with 1 M. Nothing happens to the N. So that's the answer. Triple rainbow to check. 7M times 1 is 7M. 7M times 4M is 28M. 7M times 5M N is 7 times 5 is 35. M and M makes M squared with an N. So this does check out. Here we have 6 and 28. Will 28 go into them both? Nope. Will 3 go into them both? Nope. Will 2 go into them both? Yes. So 2 is your number GCF. I see that they both have a C. The lowest number of C's is C to the second. They also both have a D. And the lowest number of D's is also to the second. So we're going to divide out 2C2, D2, 2C2, D2. 2 goes into 6 3 times. C2 and 2, when you subtract them, they cancel out. D2 and 2, when you subtract them, they cancel out. 2 goes into 28 14 times. C2 subtracts one of those out and leaves you with 1C. D2 subtracts out and leaves you with 2. Double rainbow to check it. Okay. We're going to skip ahead to number 9. The area of a rectangle, so the inside is 3x squared minus 6x, and one of the sides we know is 3x. We learned back in the last lesson when you are trying to figure out the missing side, it's a division problem. So you're taking 3x squared minus 6x, and you're going to divide out, kind of like it's the GCF, you're going to divide out 3x. So 3 goes into 3 and leaves you with 1. X goes into x2 and leaves you with 1x. Negative 6 divided by 3 is negative 2. X's cancel out. So this is the missing side, x minus 2. And you could double check it to make sure. 3x times x is 3x squared. 3x times negative 2 is negative 6x. Well, that's one the same type of problem, except they give you the length and the area and the picture of it. So we're just going to divide out the 2x. 2 goes into 4 and leaves us with 2. X subtracts out and leaves us with x to the second. Here, negative 6 divided by 2 is negative 3. One of the x's subtracts out and leaves us with 1. Here, 2 divided by 2 is 1. The x's cancel out. This is the answer. You could triple rainbow to check it.